Hey guys, so go ahead and get out your composition book because we are going to be talking about solving equations with variables on both sides, okay? And the first thing I want to tell you is when we say both sides, we're referring to the sides of an equation, okay? So we're actually going to be taking a look at this problem right here, x plus 11 equals 13x minus 1, okay? And so both sides of the equal sign would be, we have x plus 11, that's one side, and then the other side is 13x minus 1, okay? Just to be clear on that. So the first step in solving equations when you've got variables on both sides is to actually get the variables to be on the same side. So let's write that down on this side of the t-chart. Get variables on the same side. Okay, that's going to be step one if you want to know. All right, so you can move either of these terms to either side, and that's fine. But what me and Mr. Cohen's would suggest is taking whichever one's smaller and moving it. So in this case, we've got x and we got 13x. Okay, so x is the smaller one. So in order to move it from this side to this side, we need to get rid of it over here. Okay, since it's a positive x, we're going to subtract x. And if we do something on one side, we have to do it to both. Okay, so we're subtracting x from both sides here. All right. That's going to cancel these and leave 11 over here. Don't forget our equal sign. We've got 13x minus x gives us 12x. Okay, we didn't do anything with this minus 1 right here, so we just pull that down. Okay, so here's where we are. Now that we're here, we're going to move on to step 2, which, follow me here, is actually what we like to call doing PEMDAS backwards. Okay, so if I write PEMDAS backwards, that's going to be sad map. Not as catchy, but we'll work with it. Okay, so the first two letters, if we're talking about sad map, are subtraction and addition. Okay, so we're going to look for anything with subtraction or addition that's affecting the x, affecting the variable. All right. And we see we've got a minus 1 here. We want to get rid of that, all right? That's the first thing we want to get rid of. So in order to get rid of the negative 1, we got to do the opposite operation, which is to add 1, okay? And if we do something on one side, we have to do it to the other. Add 1, okay? Left side's really simple. We've got 11 plus 1, that's going to give us 12. Don't forget our equal sign. These two are going to cancel, leaving 12x. All right. Now, we've got subtraction and addition all taken care of, so we move on. Is there any division or multiplication happening to the variable? Well, yes, we've got 12 times x. That's what 12x represents. So we know if it's multiplication, we have to do the opposite operation again. So we're going to divide by 12. Opposite of multiplication is division, right? And if we do something on one side, we've got to do it to the other. So we're going to divide by 12 on this side as well. 12 divided by 12, if you can't remember, you can put it in your calculator. This can be 1. Don't forget your equal sign. These 12s cancel, leaving this to be 1x. And boom, we've got our answer, x equals 1. But we're not done yet, okay? Last step we have right here is going to be to check your answer. Okay? And I promise this is pretty painless. All you got to do is take the answer that you got for x and plug it back into the original equation to make sure it makes sense. Okay. So I've rewritten the problem just because I ran out of room. But now what we're going to do is we're going to take our answer, which was x equals 1, And so now we're going to replace all of the x's with 1s to make sure that this makes sense. So we've got an x here. Boom. There's a 1. Plus 11 equals 13 times 1. And if you'll notice, I'm putting parentheses around all of these. That just makes sure that there's no syntax errors, okay? Syntax errors is when the math's wrong, and if you put it in your calculator, it'll be like error, wrong. So putting in parentheses avoids all those issues. We got the -1. Okay, so now let's just do the arithmetic here and make sure that it's all correct, okay? So 1 plus 11 is 12, okay? 13 times 1 is just 13, and then there's the -1, okay? And I think you can all see where this is going. 13 minus 1 gives us 12. If you have a true statement, which 12 does in fact equal 12, then boom, you've checked your answer. Okay, so that's the full process. Get variables on the same side, do PEMDAS backwards, which is SADMEP, and then check your answer once you're finished. Okay, we're going to do one more sample problem, and then you can head to Math Workshop. So the next example we're going to look at is 5x minus 7 equals negative 7x plus 17. Okay, so what's our first step? Get variables on the same side. Okay, now looking between the two, we've got 5x and we've got negative 7x. So which of the two is smaller? We're going to be looking at negative 7x, right? Negative numbers are going to be smaller than our positive ones. Okay, so that's the one that we would suggest moving. Okay, and if we've got negative 7x, we're going to do the opposite, which would be to add 7x. If you do something on one side, got to do it to the other. We're adding 7x. Now, since it's an x, we can't add it to this normal 7 or this normal 17. That doesn't work. Can't add x's with normal numbers. Okay, so we've got 5x plus 7x. That's going to give us 12x. We still have our minus 7 equals, we did this so this would cancel out, and we've still got 17 left. Okay? Perfect. Now, let's move on to step 2, which is SADMEP. Okay? So let's first look for any subtraction or addition affecting the variable. We see that we've got this minus 7. Okay? So let's get rid of that first by doing the opposite operation, which is going to be plus 7. You do something on one side, you got to do it to the other. And again, we couldn't add this 7 to the 12x because that's x's and that's normal numbers. Can't do that. All right? So on this side, we've got these two that are canceling out. We're left with 12x equals 17 plus 7 is 24. All right? And now we can move on. Is there any division or multiplication affecting the variable? Yes, we've got 12 times x, which is multiplication. We've got to do the opposite operation, which is division. Divide by 12. We do something on one side, got to do it to the other. So we're dividing by 12 on both sides now. Over here, the 12's cancel. We've got x equals 24 divided by 12. It's going to give you 2. All right, so now we have our answer. Last step is going to be to check our answer. So let's do that real quick. I've rewritten the problem now, so let's put in our answer for x. So we've got 5x, so now it's going to be a 2. Notice the parentheses again, minus 7 equals negative 7x. So do parentheses again, 2 plus 17. All right, so we're just going to read it left to right. 5 times 2 is 10. Got minus 7 still, equals negative 7 times 2 is negative 14. And then we've got plus 17. All right. Next one is 10 minus 7, which is 3, equals negative 14 plus 17 is going to also be 3. So if we've got a true statement, we know that our answer is correct, and we've now checked our answer. Thank you so much for watching this video, and you're now ready for Math Workshop.